I need to make something square. Never mind what, I'll get to that later. But as of right now, I have no way of measuring how square that something will be. Sure, I have some precision squares, but these only show me if I'm square or not. They don't tell me exactly how off square I am. And I'll kind of need to know that. I'm going to need a surface gauge. So let's make one. Surface gauges are a pretty common project for apprentice machinists, so it seems fitting that I should take a stab at it myself. Before we can dive into machining though, I'm going to need a design. My rule number one for machining is that my parts have to look nice, which makes the design step kind of critical. I'm fairly partial to the old style Lufkin and Starrett surface gauge designs, so I'm working in features from these where I can. The key feature of a surface gauge is the articulating arm that holds your scribe or indicator. All of these components need to work smoothly together, but also need to be strong enough not to bend or break. There's a fine balance between appearance and functionality that takes a few design iterations to hone in on. Alright, with the design complete we can get started. This is going to be a doozy of a project, so I'm starting with the most complicated part first, the base. In true Brandon fashion, I went completely overboard with the number of features on this part. There are threaded holes, reamed holes, slots, bevels, and pockets. All perfect jobs for the mill. But instead we'll start on the lathe. Turns out the only steel I have large enough for this is round, so we'll have to work with what we've got. Facing the end will give me a square starting point for when we do move over to the mill. I'll also turn down the diameter to save myself some cutting time later. I don't have a parting blade long enough to go all the way through, so I'll just go as far as I can, then move over to the bandsaw to cut the rest of the way. Back on the lathe, we can face the other side, leaving a little extra material for cleanup later. Now this next part is likely unnecessary, but this is a case of I've got the tool, so I'm going to use it. I'm surface grinding the two faces flat to get them more parallel to each other. Straight off the lathe, these faces are probably within a couple thou of parallel, which isn't bad, but if I'm not careful, this could throw things off when I set this up in the mill. Rather than try to keep track of all that, I'll just take a few light passes on each side to get this a lot closer to parallel. That's more like it. Let's move over to the mill and make this part a little less round. I'll need to take about an inch off of each side, so I'm using a roughing mill to hog away the material. I'm using the Z-axis knee travel rather than the quill travel here. This keeps the tool as close to the head as possible where it's more rigid, which is good for these heavy cuts. But maybe not quite that heavy. To cut the other side, we just flip the part over and pick up where we left off on the Z travel. And this is where I spontaneously ruin a perfectly good end mill. Note to self, make sure your coolant doesn't run out. Fortunately, I have another roughing mill about the same size, which I promptly ruined as well. I'm batting 1,000 today. I think the second mill got fried where the first one essentially heat treated and hardened the steel. In any case, let's not do that again. This carbide insert mill should blast right through all that crap. Again, I'm leaving a few extra thou here for cleanup later. And since I've already set the precedent, we'll have to grind these faces parallel as well. See, doesn't that just look better? Back to the mill to make some more cuts. Clamping this with the two faces we just ground gives me reasonable confidence that this third side will come out square to the others. Since this will be a finished face, I'm side milling this with a conventional flute mill. And this time I'm not being stingy with the coolant. Now we can use all these fresh faces to establish a nice origin on the part for the next series of operations. The first is a pocket in the middle of this end. This mill is smaller than the final pocket width. So as I'm plunging this into the material, I'm oscillating the y-axis back and forth to reduce mill chatter. Then the final passes along the three sides mill a lot more smoothly and leave an acceptable surface finish. While we're here, we can also set up and cut the center slot that will be in the bottom. However, while setting the zero depth on the top face of the material, I noticed something was a little off. This side of the block worked its way up off the parallels, which means absolutely nothing I just cut is square. Luckily there's plenty of material left, so I'll just reset this in the vise and skim those faces one more time. Alright, back to the slot. This is a lot smaller of an end mill, so I'm being gentle with it and cutting this over several light passes. I've had enough end mill fatalities on this project already. Again, the slot is larger than the mill I'm using, so I can take a final pass on each side for a nice surface finish. While we're here, there are 4 through holes on each corner that need to be friction fit for some reference pins we'll make later. So I'll drill these out about 5 thou undersize, then use a ream to take these to final diameter. There are also a couple 832 threaded holes for set screws. These only go half the depth and will intersect with holes we'll drill later. I'd also like to point out the irony that the first holes I get to tap since making the tap wrench are too small for said tap wrench. Go figure. Before we go dismounting this, we'll just put the slightest of chamfers on all these holes. Then we can flip this over, re-zero, and chamfer the top side as well. This side of the block also has a slot. It also needs to be a pretty precise width and smooth on the side since it will be a guiding surface for the fine adjust lever. Like last time, I'm cutting out the middle undersized, then skimming each side. To help keep the sides smooth at the transition between the two depths, I'm cutting them at the same time. I just have to pause the power feed to change the tool depth and then keep going. That turned out great. Now I'm deviating from my original plan slightly. You might have noticed that the pocket I milled on the end is a bit smaller than the original design. I decided it would look better with the narrower opening and some nice little chamfers on the corners. There are probably 11 different ways to do this, but I'm just going to set the block at a 45-degree angle, then mill the chamfers with the end mill I already have mounted. Sure, it's a small detail, but I think it really adds a nice touch. Now before we can move on, I do have one small side project I need to wrap up. I designed the next feature around one of these special carbide insert mills, and let's just say they were less than acceptable to show on camera. Good as new. I need the 45-degree cutter in particular. With this, we can cut a fancy little recessed area for some finger grips, and also put a nice chamfer on each side at the same time. My plan was to sand these faces smooth, but for some reason these tool marks look extra fancy to me, so I'm making the executive decision to keep them. Next are the threaded cross holes on each side for the fine adjust lever pivot screws. And of course this tap is also too small for the wrench I made. Don't worry buddy, you'll get your chance in the spotlight soon enough. Alright, that's looking pretty good. It seems we're nearing the end of this part. Well, almost. I was going to just mill this last side square, but this curved end looks like it could be useful as an optional squareness comparator surface. It just needs to be a little thinner. I know. All these features are getting out of hand, but I promise this one will be worthwhile. It's important that this edge be very narrow, so I'm filing this down very carefully until just a hint of flat remains along the center of the edge. The tool marks left behind here are much less fancy, so they will get sanded. The last features to cut here are the 15-degree bevels on the bottom. Leaving that curved edge on one end didn't leave much material for me to hold on to, but as long as I go easy with the passes, this setup should be just fine. Oof, I love it when all the tool marks go the same direction. Now the other side. If I do this right, I should be able to mirror the tool marks on this side as well. I'm not gonna lie, that looks pretty satisfying. One last little thing I can't resist doing is taking another light dusting with the surface grinder to clear up any errant scratch marks. And with that, the base is finished. Man, that was a whole project in and of itself. But we're only getting started. Next on the chopping block is the fine adjust lever. It's both simpler and more complex at the same time, but we'll see if we can move through this one a little faster. This will also require some new techniques for me, so I'm excited to give it a try. But first we need to start with the basics and get this stock to rough size. Face milling each side gets us within shooting range of our final thickness. Then we can move over to the surface grinder for a light dusting on the faces. Because at this point, why not? Back on the mill, we'll side cut one end, the square of the material. This will give us good reference edges for the next couple of holes we'll need to drill. The first is for the swivel joint of the articulating arm, and the second is for the main pivot of the fine adjust lever. And of course these holes get the necessary chamfers. Now I'd like to show you the rest of making this part, but first we have an absolute avalanche of side projects to complete. Buckle up because this is about to get heavy. Literally. This is a rotary table. It has a lot of uses, but for this project I'll be using it to cut the external radii around each of the holes we just drilled. In theory, I should be able to mount this on the mill and position my part with the hole concentric to the center of this table. Then rotate the table to mill whatever radius I desire. But before we get there, this thing clearly needs some love. The funny thing about this rotary table is, until recently, I've never actually seen it. All the years I spent working in the shop with my grandfather, it was never used. It just sat in that giant mystery crate at the bottom of a pile of other nondescript boxes. When I would ask what the big one at the bottom was, my grandfather would tell me, but I didn't know what the words meant, and I never got up the nerve to dig it out myself and see. But here I am today, bringing it back to life after who knows how many years of being stowed away. And I gotta say, it doesn't look too bad. We just need to make some room on the mill to mount this beast. I'm still going to need the vise, so I'll just move this over. The rotary table came with some nifty T-slot mounting hardware. But of course it doesn't fit. I've got a quick fix for this though. Hang on. There we go. Being careful not to smash any fingers, we can gently set this in place and clamp it down. This definitely feels like a high quality tool, but I'm going to put an indicator on it just in case to see what I'm working with. Alright, that's promising. Not even a hint of vertical runout. Let's check in a few positions across the table to see if we're parallel to the base. I'm not seeing more than a thou of variation, and that's good enough for me. Don't get excited just yet, we still have to make some tooling to hold our part. First, I'm going to need some sacrificial material to place underneath my part so I'm not milling into the rotary table. This aluminum plate will work great, but it's not very flat. A quick skim with a fly cutter on each side fixes that. Then a couple of holes to match the positions of the ones we drilled in our part earlier. Next, we need a way to position each of the holes concentric with the center of the table. There's already a nice bore in the center, so I think we can turn down some locating pins that register on this feature. Finally, I get to spend some time with the lathe. I'm making two versions of these pins for the two different holes we need to locate on. The tolerances need to be held pretty tight to achieve the accurate positioning I'm looking for. The thickness of the larger boss is also important since it will bolster the underside of everything once it's clamped down. Almost no play at all. I'm pretty pleased with that. Now we need to come up with a clamping strategy. Ugh, you gotta be kidding me. Of course the T-nuts don't fit the T-slots. Didn't see that coming. Looks like it's just the top narrow portion that's too thick. We're already at the mill, so let's just trim these down real quick. And there goes another end mill. Apparently T-nuts are hardened. Given my luck, I feel like I should just default to carbide for the rest of this project. Man, that is some hard steel. Alright, they fit the slots now. Maybe we can finally get back to the real project and set up our part. But before we go clamping everything down, we need to establish an origin at the center of this rotary table. To do this, I'm using a coaxial centering indicator. This is another one of the fancy tools I never got to use with my grandfather. But after some fiddling, I think I've sorted it out. Once we're centered, we can zero both the axes on the DRO, and we're ready to mount the part. There are several features we'll be cutting at once, so the positions of the clamps need to avoid these areas. The rotary table is essentially adding a fourth axis to the mill, so we need to establish a zero position for it as well. To do this, we can run a dial indicator along one of the part edges and adjust the table hand wheel until the deviation is minimal across the part. Then zero the hand wheel dial, and also mark our 0 point on the circumference markings of the table. Alright, enough yapping. Let's do this thing. These first passes are at partial depth, and I'm leaving about 20 thou left on the part. Just enough for some 10 and 5 thou passes at full depth to clean up the surface and take it to size. And that turned out spectacularly. Now we can break this down and set up for the other cut using the second centering pin we made. I might need to keep the rotary table mounted up here and make up some more excuses to use it like this. I literally feel like I'm a human CNC machine. And the finish looks amazing. A few more quick operations and we can call this part finished. First we need to mill this untouched end to length. Drill and tap a hole for the fine adjust screw, then drill a hole to retain the preload spring. And finally, file a small radius on the last corner. Oh, and of course a few passes on the surface grinder to take it to thickness. In hindsight, it seems kind of silly to have put this much effort into just these two parts, but I think it's time well spent and will translate to a quality tool in the end. Or at least that's what I'm going to tell myself. The downside of taking so long is that I've completely run out of time to finish this project. Believe me, I'm just as sad as you are. Nearly all of the remaining parts will be made on the lathe, and I love using the lathe. But there's a big issue that I've been working around that I can no longer avoid. That's a bit of a problem. But the solution lies within this cardboard box. See you next time, and thanks for watching.